Welcome to The Explainer. Today we're talking about the unsung hero of pretty much every network you've ever used, the switch. You know, it's that little box with all the blinking lights that make sure your email actually goes to your boss, and not, well, the entire company. We're going to break down exactly how it works its magic.
So let's start with a really basic question. Think about it. When you're in an office and you hit print, how does your computer send that document only to the printer? How does it avoid just broadcasting it to every single phone, laptop, and server on the network? What's stopping it from just shouting into the void and hoping for the best?
Well, the answer really lies in this massive upgrade from an old, inefficient device called a hub to the much smarter network switch. Now, on the outside, they can look almost identical, but trust me, what's happening on the inside is a whole different world.
To really appreciate just how genius the switch is, we first have to understand the mess it replaced. So meet the hub. It was a simple but really sloppy way of connecting computers. It basically created one giant party line where only one person could talk at a time. Not great. This is the perfect way to think about it. Using a hub is like being stuck in a massive group chat with every single person in your phone's contacts, and there is no option to send a private message. Anything you want to send to just one person, nope, it goes to everybody. It's slow, it's noisy, and there is absolutely zero privacy.
So here's what's actually happening under the hood. A hub is, for all intents and purposes, just a dumb repeater. It has no intelligence whatsoever. When a signal comes in on one of its ports, its only job is to make an exact copy and just blast that same signal out of every single other port, whether the device on the other end needs it or not.
And you can probably imagine the chaos this creates. Because everyone is on that same party line, if two computers try to talk at the same time, their data literally collides and gets corrupted. This just grinds the network to a halt. And even worse, it's a massive security hole. Anyone connected to the hub can easily listen in on conversations that weren't meant for them.
Okay, so thankfully, engineers knew there had to be a better way. So let's finally meet the hero of our story, the smart, efficient, and much more private network switch.
So unlike the hub that just shouts at the whole building, a switch acts more like a mail carrier inside an apartment complex. It looks at the specific apartment number on the letter and delivers it directly to the correct mailbox. Nobody else even knows a letter arrived.
So, it really boils down to this simple difference. A hub is a party line where everybody hears everything. A switch creates a private, direct line between just two devices. It's the difference between a town crier yelling in the public square and a private phone call. By doing this, it takes that one big, messy, shared road and breaks it up into tiny, individual driveways for each port.
But how does it do this? How does a switch know which device is in which apartment? To answer that, we need to take a little peek inside its digital brain. All right, the first piece of the puzzle is that every single device that can connect to a network, your phone, your laptop, your smart TV, has a unique, unchangeable ID that's assigned at the factory. It's called a MAC address, and you can think of it as a permanent digital fingerprint.
Now, the switch uses these unique fingerprints to build its own internal address book. And in the networking world, this address book, the switch's brain, is called a CAM table.
And here's what that brain actually looks like. It's really just a simple table. When the switch sees a message from Mark's PC come in on port 1, it makes a note. It says, okay, this MAC address, this fingerprint, lives on port 1. It does the same for Lisa's phone on port 3, and so on. It's constantly building a map of the neighborhood.
And what's really amazing is that the switch builds this table all by itself. So let's walk through it. A message, or a frame, arrives. The first thing the switch does is it looks at the sender's MAC address. It learns. It says, aha, this device is on this port, and it records that in its CAM table. Then and only then does it look at the destination address, check its table to see where that device lives, and forwards the frame only to that one specific port. It literally learns by listening.
Now, this whole process of using MAC addresses is really important because it defines what a switch is at its core, a Layer 2 device. And to understand what that means, we need to quickly look at the difference between something called a frame and something called a packet.
A switch operates at what we call Layer 2. All that means is that it deals with data that's packaged into a frame. Just think of a frame as a local envelope. It's addressed with the to and from MAC addresses. That's the language the switch speaks and understands. So here's the best way to think about it. The Layer 2 frame is the envelope with the local mailing address on it. That's what our mail carrier, the switch, can read. But inside that envelope is the Layer 3 packet. That's the actual letter, and it contains the cross-country address, the IP address. A standard switch only ever looks at the envelope. It doesn't open the letter, so it has no idea what the IP address even is.
So let's put it all together. The switch is the hero of our story because it's a smart Layer 2 device. It cleverly uses those MAC address fingerprints to learn the layout of the network, creating fast, private, one-to-one conversations. It completely eliminated the noise, the traffic jams, and the security nightmares of the old hub. And in doing so, it became the invisible foundation of pretty much every local network we all use and depend on every single day.
The switch is just a perfect example of an elegant, invisible piece of technology that just works. It's powering our world behind the scenes right now, and it really makes you wonder, doesn't it? What other unsung heroes are out there quietly making our modern lives possible?